My name is Dr. Eldar Ochman, and today I'm going to discuss with you about the interplay between the immune system and the central nervous system. This presentation will include overview of the neuroimmune system, the interplay between stress, illness, and the immune response, the immune system and CNS interaction in psychiatric disorders, and finally, therapeutic implication. We will begin with a short introduction of the neuroimmune system. Over the past decades, studies of the nervous and immune systems have revealed bidirectional pathways, the so-called neuroimmune system, that enable immune mediators to affect neural function and vice versa. On the cellular level, interaction between immune cells and peripheral nerves allow the immune system to recruit neuronal elements for the fine-tuning of the immune response. In return, CNS immune cells regulate the elimination and plasticity of synapses, participating in the nervous system homeostasis. So how the immune system communicate with the CNS? As seen in the presented scheme, according to traditional paradigm, circulating inflammatory cytokines act on the brain via areas where the blood-brain barrier is leaky. However, the demonstration that immune-like cells in the brain as microglia produce and release pro-inflammatory cytokines led to a paradigm shift where the peripheral immune signal is transmitted to the brain by both afferent nerves and diffusing cytokines which activate the microglia. Now, I would like to walk you through the complex crosstalk between stress, illness, and immune response. Interest in the effects of stress on the immune system grew out of a series of studies suggesting that stressful stimuli can influence the development of immune-related disorders, including diabetes and cardiovascular diseases. Although stress has been historically associated with suppression of immune function, recent data indicate that stress may also activate the immune system. When challenged with a medical illness or chronic psychological stressor, complex interaction between the immune and nervous system promote a constellation of immune-induced behavioral changes referred to as sickness behavior. These behavioral changes include dysphoria, anhedonia, fatigue, social withdrawal, anorexia, and altered sleep-wake patterns. Blocking cytokine activity or treatment with antidepressants diminish the development of sickness behavior. Looking on the stress-associated changes in neuroimmune function, we can see that repeated stress exposure promotes activation of the hypothalamic pituitary adrenal gland axis, leading to release of glucocorticoids into circulation. Concomitant sympathetic nervous system activation causes release of noradrenaline into the blood. Together, glucocorticoids and noradrenaline influence the trafficking and activation state of immune cells. The neuropsychiatric disorder that has been best characterized in terms of the interplay between the immune system and CNS is major depression. Data which support the interaction between depression and immune system include the induction of sickness behavior by inflammation, as discussed earlier, elevated inflammatory markers in about a third of depressed patients, and strong association between immunotherapy and depressive symptoms. Looking on the neuroinflammatory pathways in the pathogenesis of depression, inflammatory cytokines increase peripheral glucocorticoid resistance and decrease serotonin levels by promoting transference from tryptophan to kynurenine rather than to serotonin. Considering the role of the neuroimmune system in the pathogenesis of schizophrenia, several lines of evidence suggest that infections during neurodevelopment are implicated in the causality of schizophrenia, the so-called viral hypothesis. Alternatively, an autoimmune process might be involved in the disorder as indicated in few autoimmune encephalopathies. The diathesis stress hypothesis of schizophrenia suggests a two-hit model in which environmental and genetic influences may act synergistically. Recent data suggest that genetic variation in the complement system together with perinatal stress result perinatal activation of microglia. Subsequent stress during adolescence may trigger overactivation of these primed microglia with subsequent excessive synaptic pruning associated with schizophrenia. The bidirectional nature of the neuroimmune system implies that agents that modulate immune functioning may be of potential benefit in the treatment of neuropsychiatric disorders. Indeed, several anti-inflammatory medications have been studied for their efficacy in the treatment of mood disorders. For example, a recent meta-analysis suggests that adjunctive non-steroidal anti-inflammatory drugs as celecoxib reduce depressive symptoms compared with placebo. Moreover, the monoclonal antibody infliximab, a TNF-alpha antagonist, reduced depressive symptoms in a subgroup of treatment-resistant depressive patients with high baseline CRP levels. This was a short introduction of the emerging concept of the neuroimmune system. I would like to thank you for your attention and wish you all success in your future training.